Okay, today we're going to start the first of several lessons on the topic of algebra. It's really not that hard when you get started. We just need to cover some simple definitions first. So in this section we're going to talk about real numbers and their graphs. And in order to do that we need to talk about some definitions. Now to be honest with you, some of these definitions are going to be come fast and furious, and actually some of them, to be honest with you, aren't that terribly useful, but you may be tested on them, so I'm just going to go through them real quick and try to cover the high points of what's important. The first thing is there are these things called natural numbers. Okay, and natural numbers are very simply positive numbers. So the set of natural numbers, the set meaning a collection of objects, would look like something like 1, 2, 3, 4, ... where the little curly braces indicate the fact that it's a set. Now there is also something called whole numbers, which is a set that looks kind of like natural numbers, except it includes 0. So you have 0, 1, 2, 3, ... These things are called whole numbers. And as I said, some of this stuff is trivial and looks kind of silly, but you may be tested on this stuff. Now the next one is actually kind of important. These things are called integers. And these numbers are basically the set of positive and negative numbers. You'll hear a lot about positive and negative numbers here in algebra. So the set of integers looks something like -2, -1, 0, 1, 2, ... and ... on this side. So basically all the positive and negative numbers. And negative numbers, if the concept is new to you, is basically the opposite of a positive number. I mean, there's negative temperatures, there's negative, distance below sea level would be like a negative number, negative 35 degrees. Anything below 0 is just another number, but you pick an arbitrary point called 0 as the reference, and the negative numbers are just below that point. So having looked at those, let's go and take a look at a few more. Namely, we're going to talk about something called rational numbers. There's also something called irrational numbers, and they're equally important. Rational numbers, in a nutshell, rational numbers are numbers that can be written as a fraction. Let me give you an example. 3/2 is a fraction. That is a rational number. And if you do that in your calculator, that comes out to 1.5. The decimal 1.5 can be written as a fraction, so it's called a rational number. Another example would be -45/9. That number can be written as a fraction. It is a fraction, so it's a rational number. 0.25, which is half, 1/4 of 1, is also looks something like this, 1/4. So therefore 0.25, 1/4, but one and the same. Those two numbers are called rational numbers. So any number that can be written as a fraction is a number called a rational number. Now, why do we call them rational numbers? I suppose somebody thought that they look kind of nice because they can be written as fractions. Now, there is something called irrational numbers. Those numbers, as you might guess, are numbers that cannot be written as a fraction. And you might say, well, what kind of numbers are those? Well, numbers like pi, very special numbers. 3.14159 ... Pi is a number that goes on and on and on for infinity. And there's no way possible to write pi as a fraction. You may have heard in class that pi is something like 22/7. Well, actually 22/7 is simply an approximation. If you do this in your calculator, it does not equal the full length of pi. Another example would be something like the square root of 2. If you put that in your calculator, you get a bunch of numbers, but there's no way to write that number as a fraction. It cannot be written as something divided by something else. So those are called rational numbers. And irrational numbers are numbers that can be written as a fraction. And irrational numbers are numbers that cannot be written as a fraction. And then finally there's something called a real number. And real numbers are very simply, real numbers are almost everything. A real number is any number that can be rational or irrational. And you might say, well, what else is left over? If it can be written as a fraction, meaning that there's rational, and written as a not as a fraction, meaning that it's irrational, what else is there? Well, there's something called complex numbers that have the letter I in there. Those are complex, or imaginary numbers is another word for it. Those would not be real numbers. Those are imaginary numbers. So basically any number you can think of that doesn't have I in it is a real number. Negative 3, 25 over 2, negative 17 over 9. All these numbers are real numbers. 0.69. All these numbers are real numbers because they're either rational or irrational numbers. Next, we want to talk about something called a prime number. You're not going to use this stuff right away, but I just want to go over everything. A prime number is a number greater than 0, actually greater than 1, that can only be divisible by itself and 1. So let's take a few examples. 3. The number 3 can only be divisible by itself, 3, and 1, and those are the only two numbers that can be divided into 3 to give you a whole number. If you divide 3 by 2, you get 1.5. So it's not divisible by 2 equally. You can't divide it by 5, you can't divide it by 7, you can't divide it by anything. But if you divide 3 by itself, you get a whole number, and if you divide 3 by 1, you get 3, which is also a whole number. So if it's only divisible by itself and 1, it's called a prime number. Another example is 7. 7's a prime number. If you divide 7 by 3, there's going to be 6 point something. Do that in your calculator. And it does not equal a whole number. So 7 is another number that can only be divisible by itself. 7 over 7 is 1, and 7 over 1 is 7. Those are the only two numbers that can be divisible, divided into 7 to give you a whole number. So that's a prime number. Let me give you an example of a number that is not prime. 6. 6 can surely be divided by itself. 6 can surely be divided by 1. But 6 can also be divided by 3, which will give you a whole number of 2. So therefore 6 is not a prime number because it's divisible by something other than these two things to give you an even number there, a number without a decimal point. So prime numbers are very special numbers. The set of prime numbers looks something like 2, 3, 5, 7, 11, and you could go on and on. All those numbers can only be divisible by themselves in 1, and that's why they're called prime. So it's a very simple little test you apply to see if you're prime. There's also even and odd numbers. And these numbers, let's give some examples of even numbers. Basically, it's like counting by twos. 2, 4, 6, 8, 10, ... If it's divisible by 2, it's an even number. This also goes for the negative numbers. Negative 2, negative 4, negative 6, ... negative 8, negative 10. Those are all even numbers. And we'll talk about the fact that you can divide negative numbers by positive numbers and all that. But for now, just consider them the same. Anything that's divisible by 2 is called an even number, and the other things are called odd numbers. So odd numbers are numbers that look something like 1, 3, 5, 7, 9. Now notice all these are odd, and it just so happens 1, 3, 5, and 7 are prime numbers also. 9 is not a prime number because 9 can be divisible by 3, which will give you 3. So that the definition of a prime number does not apply there. But they are odd numbers. Now, one thing, let's go ahead and get into some real math instead of talking about definitions. In algebra, there's a lot of symbols, and you need to understand what the symbols mean, and that will really help your life out. So let's go over a couple of quick symbols here. Of course, there's the equal sign symbol, okay? And that means, 2 equals 2. There you go. That's your first equation. 2 equals 2. That's always true. It's kind of a silly, stupid equation. 2 is always equal to 2. But the equal sign means both sides of that equation are equal. You can also write something like 3 does not equal 2. And the little equal sign with the strike through it means not equal. So anytime the things are not equal, you put a strike through. Now we're going to get into some inequalities. We can say 2 is greater than 3. This little symbol means greater than. And basically the way you look at it is the big side here, the side that's open up, is the larger side. And actually, I've made a mistake here. That's actually not true. 2 is less than 3. So it actually looks like this. 2 is less than 3. So the way you read that is 2 is less than 3. The little pointy side means less than. This side means greater than. Or if you want to read it in this direction, you can say 3 is greater than 2. Both are equally correct. 2 is less than 3. 3 is greater than 2. Again, flipping it around, you could say 5 is greater than 1. And all we've done is flip the symbol around to suit our needs. 5 is greater than 1. The open sign means you basically read it. I always read it in the direction of the arrow as a greater than. Now, what if you have something like, let's introduce a quick variable here. Let's say I was dealing with some variable. We're gonna call it x. X can be some number, and I don't even know what x actually is. It's just some number, and I can say x, like that, is greater than or equal to 6. Now what I've written there is a new symbol, and it's not greater. It's not simply greater than. It's greater than or equal to. That is what the line under there means. So greater than or equal to 6. That means x must be either 6, 7. So you can just do it like this. So 6 must be equal to, x must be equal to 6, 7, 8, 9, on up, because x is always greater than or equal to 6. And there's also an equivalent less than or equal. You can say y is less than or equal to 3. And that means that y must be either 3, 2, 1, 0, -1, etc. So basically you have greater than or equal to, less than or equal to. And that's going to be pretty important later on. Now let's use some of these concepts and talk about graphing with the number line. We're going to actually do a little bit of simple graphing just to see how negative and positive numbers kind of add up and mesh with each other. And so we're going to introduce something called the number line. Here is the set of all numbers. It goes on to infinity in both directions, and here is 0 at the center. To the left-hand side of 0, I have my negative numbers, -1, -2, -3, and it goes on down to negative infinity over here. To the right-hand side, I have +1, +2, +3, and again, to the right, it goes to positive infinity. And this is what we call a number line. So if I want to graph the number -1, -1 is going to fall on the number line right there. If I want to graph the number plus 2.5, that number is going to be right here, right between 2, right between 3. 2.5 falls right there. Okay, and you can also graph points in between. Let's say that I want to graph. Let's just start over here. Let me go ahead and draw my number line a little bit. So that's how you can graph individual points on the line. Now what if we want to graph something a little bit more impressive? Let's draw again. Always start out by drawing your number line. Put your 0 in the middle. -1, -2, -3. Again, it goes on to negative infinity. 1, 2, 3, and again it goes on to positive infinity. Now let's say I want to graph the equation. Let's say x is greater than -2. Now we just find -2 on the number line, and we want to somehow draw on this line the set of all points greater than negative 2. I want to draw a circle here. I'll explain what the circle means in a minute. And then I want to shade in on the number line in dark pencil or whatever you're using all these points off to the right. These are all the points greater than negative 2. I put an empty circle here because we're graphing x is greater than negative 2. I haven't said it's equal to negative 2. So this represents all these points but not including negative 2. If I were to change this equation to greater than or equal to negative 2, then I would fill a dark circle here, and then this graph implies that I'm now graphing minus 2 and all the points to the right of minus 2. Okay? And you can do the same thing going in the other direction. If you're going to do, x is less than minus 2 or something like that, you would graph it off to the left. Now let's do something a little bit more interesting. Let me draw my number line. 0, minus 1, minus 2, minus 3, 1, 2, 3. Now let's say I'm going to graph something that looks like x is less than negative 3 and x is greater than 1. What would that look like? Well, there's no equal signs here, so I got to do empty circles. And the first one, less than negative 3, is going to be everything to the left on to negative infinity, because that's all the points there. And then the second one is going to be an empty circle with all the points going to the right like that. So this graph is all of the points to the left of negative 3, lower than negative 3, and all the points to the right of positive 1, but the points in the middle, including negative 1 and negative 3 and positive 1, all of these points in the middle are not included in the graph. They are not graphed there. So that's an example of what one of those looks like. And we'll do one more of these just to get the point across. If I go off like this, and again put 0, 1, 2, 3, minus 1, minus 2, minus 3. And I can write this a few different ways. I can say, let's just do it this way. Instead of writing it down and graphing it, we'll graph it first and then write it. Let's say I want to write the equation for the set of points that goes in between here and here, inclusive. So all these points in the middle there, I want to write an equation to represent. Well, over here, I'm graphing the union of x is greater than negative 2. Okay, so all the points to the right off to positive infinity, but I'm also imposing another condition that x, greater than or equal to negative 2. And I'm also imposing a condition that x must be less than or equal to positive 3. Both of these things taken together gives you the graph up here. X is greater than negative 2, meaning you start over here and going this way, and x is less than 3, meaning you go this way. And when you take them both together, you end up with this set of points in the middle, including the 2 there. Now I can summarize this by writing it slightly different. What I do is I start by putting my x here, and I say greater than or equal to negative 2, and I say less than or equal to 3. Now look at this carefully for a minute. I've rewritten it on the left into the form on the right. All I did was put x in the middle, and I exactly wrote it the same way as I wrote it here, greater than negative 2, and I've kind of turned this around, but notice the pointy end is always pointing in the same direction. Here, x pointing with a less than or equal to 3, x with a pointy right next to the x, less than or equal to 3. This is the form that you'll typically see it. And all you have to do is read two separate ways. X is greater than minus 2, x is less than positive 3. And then you'll end up with a graph something like that. The only other thing I want to talk about briefly before going in and getting into the actual problems and working a good bit of problems here is I want to talk about absolute value. Absolute value is important in algebra, and basically it goes something like this. We'll go back to the number line, okay, and we'll say 0, 1, 2, 3 for our number line, minus 1, minus 2, minus 3. Okay? And then I want to say, what is the absolute value of 3? Absolute value is kind of like distance from 0. Here's the point 3 on the number line. When I say the absolute value of 3, all I mean is pretty much you take what's in the inside and you write it down. That's what the answer is. Absolute value means how many units am I away from 0. In this case, I'm 1, 2, 3 units away from 0. The absolute value of 3, so the answer is 3. Now, what's the absolute value of negative 2? How many distance units is minus 2 away from 0? Well, I'm going in the negative direction, but I'm 2 units away. So the answer to that is 2. The little brackets around the number means absolute value. So absolute value of negative 2 is 2. The secret to this is just anything inside the brackets. You could just strip out the sign, and that's the answer. So if you're looking at absolute value of negative a, the answer is always going to be a. Anything inside there, you just take the negative sign away, and that is the answer. And that'll do it for this. We'll pick it up in the next video clip with some more examples from this section.